Okay, so good morning, dear students. Today we are going to solve October-November 2005 MCQ paper. This is called paper 1, and this course is Physics 5054. So let's start. The question number 1 is showing up on your screen. We have to find out what's the reading on the Vernier caliper. So this is the main scale, and this upper thing is the Vernier scale. So what I will do, I will check the zero of the Vernier scale, how much it has crossed on the main scale. So if you look at here carefully, the zero of the Vernier scale has crossed 2.3. So in your rough work somewhere write 2.3, and then I will check that which line of your Vernier scale is coinciding with the line of main scale. So if you check carefully, you will find this third line is most coinciding. So 1, 2, 3. So after that number, you will write 3. So the reading is 2.33. So C is the choice. So that was question number 1. So now let's move to the question number 2. The question number 2 is showing up on your screen. And let me close this. Okay. An aircraft flying at a constant height is gaining speed. The four forces acting are: L is the lift due to the wings, and R is the air resistance, and T is the thrust due to the engines, and W is the weight. So you can see that I have highlighted the word constant height. Constant height means the plane, the upward and downward forces, they are balanced with each other. So it means W and the L, they both are balanced. That's why the plane is flying at a constant height. And because the plane is gaining speed, for example, if you look at here, it says the gaining speed. If it is gaining speed, then this thrust is more than the air resistance. So look at here. So the L and the W, they should be equal to each other, and T is more than the R value. T is more than the R value. I think this is the answer. What you say? L and W, they will be equal because the aeroplane is at a constant height, and the T is greater than the R because the aeroplane is gaining speed. So C looks the best answer to me, and let's check from the marking scheme. So let's check from the marking scheme what the marking scheme has to say. C is the right answer, sir. Okay. So we will be going to the next part, and the question number, this is question number 3 showing up on your screen. He says, what must change when a body is accelerating? What must change? The body accelerates when the magnitude of the velocity changes, or you can say the direction of the velocity changes. In other words, you can say the velocity is changing. So he says, what must change when a body is accelerating? The force acting on the body, the mass of the body, the speed of the body, the velocity of the body. I think the most appropriate word for acceleration is that the velocity must be changing. The most appropriate word here is that the velocity must be changing. So I think that D will be the answer. So let's check the marking scheme. What the marking scheme says, question number 3, D is the choice. So our answer is right. Okay, so here we go. Question number 4. The graph illustrates the motion of an object. Okay, so it's a speed time graph. On the y-axis, the speed is represented. On the x-axis, the time is represented. Which feature of the graph represents the distance traveled by the object whilst moving at a constant speed? And when it's moving at a constant speed, you see the distance traveled is equals to the area under the speed time graph, and they are saying distance traveled when the object was moving at a constant speed. So you see this portion represents the constant speed. So the area under this is that distance he's talking about. So he says which feature of the graph represents the distance traveled by the object whilst moving at a constant speed. So that is the area T. So I think C is the answer. C looks the best answer to us. Okay, let's check that. This is question number 4. Question number 4, C is the right answer, sir. Okay, so we are moving to the question number 5. He says a body P moves in a circle around a point S. A force F keeps it moving in the circle. Okay, what happens if the force F suddenly disappears? If this force, which is a centripetal force, that will disappear. For example, the point P is here, and this is the tangent. If this is the tangent, so the P will not move in the circle, it will go along its tangent. If this F force disappears, what will happen? If you draw a tangent here, the P will go along its tangent. Okay. So what happens if the force F suddenly disappears? P moves directly towards S. That is wrong. P moves in a circle closer to S. No. P moves away from S in a curved path. No. P goes off in a straight line. Yes, that is true. The P, I told you that if you plot a, draw a tangent here, because the body is going in this direction. So if you draw a tangent here, so at this moment, if the F force disappears, this P will go along its tangent, which is a straight line. So I think D is the best answer. This one is a little tricky. Do you understand this? 5 is D. 5D is the right answer, sir. An object that has a mass of 15 kg on the earth is taken to the moon. An object that has a mass of 15 kg on the earth is taken to the moon. The gravitational field strength on the earth is 10 newtons per kg and on the moon is 1.6 newton per kg. What are the mass and the weight of the object on the moon? So the mass of the object is 15 kg. The G value on the moon is 1.6 newtons per kg. So when you will go on the moon, you see, let me show you this. Okay, so here we go. So the mass of the object is 15 kg on the moon. The G value will be 1.6 Newton per kg. You see, if you go on the moon or you are on the earth, the mass remains the same. So the mass will be 15 kg on the moon. The weight I can calculate. The weight is equals to mg. The m value will be 15. The G value on the moon is 1.6. So the weight will be 24 Newton. So the weight will be 24 Newton. So let's check what are the options. So the mass will be 15 Newton, 15 kg and 15 kg and the weight will be 24 Newton. So I think A is the choice. Question number 6, A is the choice. So let's check. Question number 6, A is the right choice, sir. Okay, so we are going to the next part and this is, let me reduce the size. Okay. Oh, this question is huge. Okay. So, but we have to reduce the size. Okay. So here on your screen, a question question number 7 is showing up. A student is trying to find the density of a stone, but he has mixed up the instruction cards. So card number 1 is find the mass of the stone using a mass balance. Okay. Read the new level of the liquid in the measuring cylinder. Okay. Put the stone into the liquid. Okay. And divide the mass of the stone by its volume to find the density. And put some liquid into a measuring cylinder and read the level of the liquid. Okay. Flick the cylinder to get rid of any air bubbles. Subtract the original volume of the liquid from the volume of the liquid plus the stone. Okay. So See how this how you will do this. The order has been mixed. So what how I will do this, you see, very simple. Let me show you. So let me show you. I put it here. Okay. So what I am going to write. First of all, I think I should do one. Then means find the mass of the stone using a bin. Then I should take a cylinder and put a measuring cylinder, I mean, and then put some water in it. So then I should take 5. Then I should note down the mass, the volume of this. Then I should put the stone into the liquid. Then I should do the 3. Okay. Then I should flick the cylinder to get rid of any air bubbles. Then I should do 6. Okay. Then I should read the level of the liquid in the measuring cylinder. Then I should do 2. And then subtract the original volume of the liquid from the volume of the liquid plus the stone. Then we should do the 7. And then divide the mass of the stone. Then we should do 4. Then we should do 4. So the order of that, how you do this experiment should be 1, 5, 3, 6, 2, 7, and 4. So I think B is the right option. Do you understand this? This is easy.
Yes.
Okay. So I think B is the right answer. Hello? B looks the right answer to me. So question number 7, B is the right answer, sir. Okay, so we are going to the next question. He says a tractor is being used on rough ground. What is the safest position of its center of mass? The safest position of the center of mass should be nearest to the ground, and it should be passing through the base of the tractor. It should not go out of the base. So D looks the best option, sir. D is the best position where the base of the the center of the mass of the tractor should be. So question number 8, I think D is the answer. So we are right. D is the right answer. Okay. Question number 9 is showing up on your screen. A plane lamina is freely suspended from the point P. The weight of the lamina is 2 Newton and the center of the mass is at the C. The lamina is displaced to the position shown. What is the moment that will cause the lamina to swing? Okay, so try to understand this diagram. So this is the pivot and this is the card. So it's a lamina. And here we have a hole at the points P. And here we have nail. So this lamina is hanging on this point at P. Here we have a nail. So it's freely suspended and it can rotate actually on that point. So here we have the center of its mass. So all its weight will be acting here at point C. So this will cause, because you see this is on the right side of the pivot, so it will try to produce a clockwise turning effect. It will try to produce a clockwise turning effect in this lamina. Let me show you how I have done this. I have done this on a paper. Let me show you. So, so here on the diagram, you can see at the point C is the center of the mass. So the whole weight is acting here. So this is the line of action of the weight. This is the line of action of the weight. And it will be trying to produce a clockwise moment about this pivot. Okay. So if you want to find out the turning effect or moment produced by this in the lamina, that will be equals to the weight, which is 2 Newton, multiply the perpendicular distance between the pivot and the line of action of the weight. line of action of the weight is this, and its perpendicular distance from the pivot is this, and this will be equals to the QC. This will be equals to the QC. That's the perpendicular distance between the pivot. You can see here. This is the perpendicular distance between the pivot and the line of action of the weight. So that is 0.3 Newton. So the moment will be weight multiply perpendicular distance between the pivot and the line of action of the weight, and that will be 2 multiply 0.3. So 2 is the weight of the force, the weight, and QC that's 0.3. So the final answer will be 0.6 Newton meter. So let's 0.6 Newton meter. So let's see from there. 0.6. So A is the choice. Do you understand this question? Question number 9, A is the choice. A is the right choice. And let's check the marking scheme. Question number 9, A is the right choice. Do you understand this question?
Yes, sir.
Okay. 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 So the next question coming up. So you see, this is the pivot. Here we will have the line of action of the weight. If you want to find out the moment produced by this, that will be equals to the weight multiply the perpendicular distance between the pivot and the line of action of the weight. So, for example, let me show you from there. So this is that line of action. This is that line of action. This is that line of action of the weight. This is that pivot, the nail there. This is the perpendicular distance, which is 0.3. That will be equal to this thing. So that is 0.3 meter. The weight value is 2 newtons. So simply multiply them. That will give you the moment produced by this weight in that lamina. Okay. So we are on the question number 10. Two forces act at right angles at a point O as shown. What is the resultant of the forces? You see, here we have two forces. I want their resultant. The both the forces making 90-degree angle with each other, and we have put these forces in such a way that their tails are joined. If the vectors, force is a vector, if the vectors to be added, you put them in such a way that their tails are joined, then you can find their resultant by parallelogram law. So in parallelogram law, we suppose that these vectors are the sides or the adjacent sides of a parallelogram, and you complete the parallelogram. So what I will do, I will complete the parallelogram. You can see we have completed the parallelogram, and then you can find the resultant. How you find the resultant? Where the tails are joined, you join that point with the opposite corner. That gives you the resultant, and that also gives you the direction. So let me show you. So question number 10 is showing up on your screen. You see 9 Newton, 12 Newton, their tails are joined. I completed the parallelogram OPQR, and the resultant will be you join the point where the tails are joined with the opposite corner, and that will be this line. So because it's a right angle triangle, very easily you can find the resultant by applying the Pythagoras theorem. This black line is the hypotenuse of that right angle triangle. So I applied the Pythagoras theorem. So that will be OQ square will be 12 square plus 9 square. So OQ finally will be 15 Newton. And its direction is from O to Q. Okay. Its direction is from O to Q. By the parallelogram, we have found the direction and the magnitude. So the magnitude is 15 Newton and the direction is from O to Q. So I think that the choice is A. I think that the choice is A. Question number 10, choice is A. Let's check first of all. Question number 10, choice is A. Okay. Do you understand this question?
Yes.
Okay. So let's move to the next question. A mass hangs on a string fixed at point P. It's like pendulum. It starts from position 1 and swings to the furthest position on the opposite side, position 2. It then oscillates several times with decreasing amplitude before ending at the position number 3. Okay, so it vibrated and then obviously after some time it stopped. Where does the ball have the most kinetic energy? Okay, so whenever the pendulum is swinging, remember that when the pendulum reaches its extreme positions, for example, at position number 1 or position number 2, the pendulum always stops. The pendulum stops and then it changes its direction of motion. For example, at the position number 1, the pendulum will be at rest and then it will go towards the right side. When the pendulum will reach the position number 2, it will stop and then its direction of motion will change. It will go back to the left side. So at position 1 and position number 2, the velocity of the pendulum is zero. Its kinetic energy will be zero. The position number 3, which is in the mean, which is actually the mean position, here the pendulum has the maximum speed. So wherever the pendulum has the maximum speed, there it has the most kinetic energy. So at the position 3, the kinetic energy will be maximum. So he says, where does the ball have the most kinetic energy? I think the first time at the position 3. This the last time at the position T, the last time it will stop there. So its velocity will become zero. So if the first time when it crossed the position 3, it has the maximum speed. So at that time, at the position 3, the body has the maximum kinetic energy. So I think C is the choice. Question number 11, C is the choice. Okay, so C is the choice. What do you say? Do you understand this?
Yes, sir.
Okay, here we go. A girl of weight 500 Newton runs up a flight of stairs in 10 seconds. The vertical height of the stairs is 5 meter. What is the average power developed by the girl? So you can see that here we have 500 Newton. The weight of the girl is 500 Newton. She went up in 10 seconds, and the vertical height she gained is 5 meter. So their question is, what is the power? So the power is equals to work done divided by time. The power is equals to work done divided by time. And when you go upward, the work done, the useful work done is equals to the weight multiply vertical height. Weight multiply vertical height. And if you divide it with the time taken, you will find the power developed. Okay, let me show you. I have done this also, and let me show. Okay, so the next question. So the power is equals to actually work done divided by time. So that is weight multiply height. That is work done divided by time. So 500 Newton multiply 5 meter vertical height. I mean, divided by time. That's 10 seconds. So you will have 250 watt. 250 watt. So the power developed is 250 watt. I think. Let's check the answer. 250 watt. 250 watt. C to us, C looks the right answer. Let's check. Question number 11, C is the right answer. Question number 12, sorry, this is question number 12. C is the right answer. Do you understand this question?
Yes, sir.
Oh, if a brick of weight 80 Newton stands upright on the ground as shown, what is the pressure it exerts on the ground? The pressure exerted on the ground is equals to the weight of the brick divided by its contact area with the ground. The weight of the brick divided by its contact area with the ground. The weight of the brick is 80 Newton divided by the contact area face of the brick which is in contact with the ground. Its weight, its dimensions are 10 centimeter and 5 centimeter. So the pressure will be 80 divided by, and in the downstairs in the numerator you will write 10 multiply 5. So I think that C is the best option. I think question number 13C is the right option. Let's check. Question number 13C is the right option, sir. You understand this question?
Yes.
We have to reduce the sign a bit. Manometer is connected to a gas supply. Pressure can be measured in centimeter of water. What is the pressure of the gas? Okay. So here you have connected the gas cylinder. So here the gas supply is, and here we have the atmosphere, and this the level of the water. Here you see the level of the water is lower. Here the water level of the water is higher. This means the gas supply's pressure is more than the pressure of the atmosphere. The gas in the cylinder has pressure more than the its pressure is more than the pressure of the atmosphere. But how much? How much? Okay. So let's check what's the difference of levels the of the water in both the limbs. So here and here, the level of the water is here. So difference between these levels is only 8 centimeter. So the difference of the level is 8 centimeter. So the pressure of the gas is 8 centimeter of water more than the atmospheric pressure. Because on the gas side, the level is lower, it means the gas pressure is more than the atmosphere. But how much? The difference of the level in both the limbs, that is 8 centimeters. So the pressure of the gas is 8 centimeter of water more than the atmospheric pressure. So I think is the choice. What do you say? Do you understand this?
Sir, we can see you mean.
Question number 14. 8 centimeter of water less than the atmospheric pressure. Because this gas, it has pushed the water into this. So here the level of the water is lower, here the water level of the water is higher. So it means the gas pressure is more. It has pushed the atmosphere backward. Okay?
Okay,
The
sir.
gas has pushed the atmosphere back, the atmospheric pressure. It has pushed this water into that limb which has the atmosphere. So it means that this gas has more pressure. How much more? The difference of the level. That's 8 centimeter. So the gas has more pressure. How much more? 8 centimeter more than the atmospheric pressure. The pressure of the gas is more. The pressure of the atmosphere is less in this case. What do you say?
Okay, sir.
Okay. So question 15 is showing up on your screen. What will not affect the rate of evaporation from the surface of the liquid? The depth of the liquid? Oh, yes. The depth of the liquid does not affect the rate of evaporation. Draft, drafts above the surface of the liquid, the winds which are blowing above the surface of the liquid, and they affect the rate of evaporation. Surface area of the liquid, that affects the rate of evaporation. Temperature of the liquid, that also affects the rate of evaporation. So the which thing which do affect the evaporation of a liquid, that is the depth of the liquid. So We are looking for that which do not affect the rate of evaporation. So question number 15, A looks the right answer. Question number 15A is the right answer. Okay, the next question is what makes a thermometer sensitive to small changes in the temperature? If you want to make a thermometer more sensitive, you can do a few things. One, the radius of the bore of the capillary that should become smaller, or in other words, the diameter should become smaller. It should be narrow bore. Another thing you can do, you can use a liquid which expands more, or you can use a larger
Sir,
bulb and put more liquid in it. So these are the three things you can do to make a thermometer more sensitive. Yes,
एक यूनिट
a bulb with a thin glass wall. A bulb in which you have the mercury, its walls are thin, so it does not have any effect on the sensitivity. Sensitivity means that how much the length of the uh, mercury will change for 1 degree rise in the temperature. So it has nothing to do with the thin walls of the glass. They can make very responsive thermometer, which respond quickly, but it cannot make it more sensitive. Sensitive means that how larger a change in the length of the mercury column will show up when a certain for every degree rise in temperature or drop in temperature. A shiny liquid in its bore, no. A stem with a with a thick glass wall, no. A very narrow bore, yes. When you make the bore of that capillary in which the mercury travels very thin, for the same rise of the temperature, it will show a larger change in the length of the mercury column. So that's make it more sensitive. So I think D is the choice. Let's check first of all. Question number 16, D is the choice. Question number 16, D is the choice, sir. A hot liquid is carefully poured into a beaker. The graph shows how its temperature changes as it cools towards room temperature. So it's cooling down. It's a liquid actually. It's a hot liquid which is cooling down. So whenever the temperature, this cooling curve will become flat, it will mean two things. It means that the state is changing, or it means that the room temperature has reached. So you can see that when this became flat, so what will happen at X? It was a hot liquid. The cooling curve came down, and then it became flat. So which process are taking place at the region X? At the region X, this liquid is actually converting into solid. That's why the cooling curve has become flat. So it is basically converting from liquid to solid. And evaporation obviously goes on. So it's solidification and the evaporation is happening. Okay, so what is the answer? I think B is the best answer. Do you understand this?
सर इवेपोरेशन सॉलिड जब हो रहा है तब साथ साथ हो सकती है
Because at the X there will be some liquid present and that liquid will be converting into the solid, so evaporation will be happening.
मतलब कुछ सॉलिड में कन्वर्ट हो रहा है कुछ इवेपोरेट हो रहा है लिक्विड
Yes, 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 yes.
ओके
The
सर
process of solidification is taking place, and during that obviously the evaporation is also happening. Question 17, D is the answer, so our answer is right. Okay, so we are moving to the next part, and that part is question number 18. The diagram shows a room seen from above. It is cold outside the room. The room is heated by a small fire in the fireplace. Where is most heat lost by convection? So by convection, I think that you need air or you need liquid. Convection only happens when you have air or you have liquid, when you have a gas or you have a liquid. Okay, so it's, you see this chimney for the waste gases, and it's exactly above that. You have that fireplace where the fire is burning. So here you have the chimney for the exhaust gases. So most of the heat will be lost by convection through this chimney. It's a straightforward question. For convection, I need air or a gas or a liquid. So where does that thing is available? In the chimney. So through the chimney, most of the heat lost is by convection. So heat is lost. Question number 18, I think B is the right answer. Question number 18,
Sir,
B
please
is the right
दोबारा
answer.
explain कर दो.
You see, his question is, where is the most heat lost by convection? That's the question. So where is convection happening? Convection can only happen if you have a connection between the inside of the room and the outside of the room and air in that case. So that is through the chimney. Chimney is one thing which is connected with the outside world and is also connected with the inside. Okay. So what will happen? The heat will be lost mostly through this. Okay. So is this clear? By convection, the heat will be lost. You see, unfortunately, due to the light shortage, my UPS has started alarming. So this call will end anytime. So it's better to stop this here at the question number. Oh, the light is back. The Wabda light is back. Okay, so we can continue. So we have question number 19. An experiment is carried out as shown in the diagram. Okay. So he says, why does the ice takes a long time to melt, even though the water at the top of the tube is boiling? Okay, so here you have a test tube, here you have a ice cube, and you have put a metal gauze to keep the ice cube at the bottom, and you have little tilted this is filled with the water, and here you are boiling it with the Bunsen burner. So this place is boiling, the water here is boiling, but the ice cube here do not melt for a very long time. Okay, it will eventually melt, but for a very long time this ice cube will not melt. Why? Why does the ice take a long time to melt even though the water at the top of the tube is boiling? The reason is, by the convection, how the heat will reach the ice cube? Water is liquid. So by convection, the heat can reach the ice cube. But the problem is, by the convection, the heat only travels upward. So from here, by convection, the heat can only go upward. Only go upward. Another way of for the heat to reach from this point to the ice cube is by conduction. Convection, through convection, the heat cannot come because heat goes up. By conduction, it can come here, but the problem is the medium is water, which is a liquid, and water is a poor conductor of heat. So that's why through the conduction, the heat has not reached here. Convection never occurs in water. That's wrong. Ice is a poor
Sir,
conductor of the heat. This is the gauze prevents the energy reaching the ice. Water is a poor conductor of the heat. Ice is a poor conductor of heat. No, 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 no. The choice is D. Choice is D actually, not this one.
sir,
The D is the choice. The power is a water is a poor conductor of heat. Yes.
sir, तो गॉस का कोई रोल नहीं होगा इसमें.
Gauze, so we put there just to keep the ice cube at the bottom. Otherwise, ice cube will float on the water. It will
जी
come
sir.
up automatically. So gauze is there to keep it there at the bottom. Otherwise, the ice
Okay.
cubes will float on the water. So the answer is D. Because the heat is not reaching here because water is a poor conductor of heat. Okay. So that was question number 19. I think D is the answer. Question number 19, D is the right answer. Okay. Question number 20 is showing up on your screen. The diagram shows a wave on a string with 2 points P and Q marked. The wave is moving in the direction shown. Okay. What will happen next? Okay. So this wave is going in this direction. This wave is going in this direction. So, for example, if I take this point, what will happen with this? So, whatever is behind it, that will happen next. So, for example, at Q, the wave is going towards the right. So, what will happen with the Q? Whatever is happening behind it. So, that is going to happen with it. Next, 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 this will happen. So, this Q will move upward above the mean position. So, what will happen with the P? What is happening behind it? It will go down. It will go down towards the mean position and then down. So what will happen next? The P will move to the right? No. The P will move up? No. Q will move. Q will not move. That's wrong. The Q will move up. Yes, this will happen. The Q will move up. Remember this thing. Just this should be on your finger. This wave here. This wave is going to the right. So if you take any point, any particle of the medium in this wave, and you want to know what will happen next, what will happen next, what will happen in the next moment, whatever is happening behind that point, that will happen with that point after a moment. So what will happen with the Q? What is happening behind it? The wave is above the mean position. So this Q will move up. Okay? Do you understand this? It's a very important concept. Do you understand this?
Yes, sir.
Okay. So we are done with the October, November 2005 Physics 054 paper 1. We have done the first 20 questions, and so this will be, we call it, this is the part A of our lecture. We will do another lecture today on this paper, and we will complete this paper. I will upload both these videos in my YouTube channel, and you will be able to watch them. So I think your lesson is also over. So thank you very much, everybody. It was a pleasure teaching you all. So I hope that this video will be helpful to you. So thank you very much, everybody. Have a good day.